Hi, in this video, which is less than 5 minutes, I'll take you through an important solved problem on kinetic friction and including the Newton's second law of motion. So we have a block here in this problem which has already started sliding, so we talk of kinetic friction. The block has been pulled by a rope which is wound around a pulley, and at the other end of the rope a sphere is hung which provides the force to pull the block. The value of kinetic friction is given in the problem, and we have to find out 4 things: rope tension, frictional force, normal reaction on the block, and the accelerations of the block and sphere together. So let's first draw a sketch. We have a sketch here. The horizontal plane is clear. There is a green colored block with 10 kg marking on it, which is accelerating from left to right. There is a yellow arrow with a marking T, which is the rope tension, which is pulling the block from left to right. At the other end of the pulley, we have a 6 kg sphere, which is having a weight acting downwards, and therefore it pulls on the rope. The rope tension is the same everywhere along the rope. On the block side, we have the other forces indicated: the upward normal reaction, the downward weight mg, and the backward frictional force, which is shown as a red arrow. The important thing here is that the rope does not get any longer, the rope does not have any mass and does not add to the mass of the system. Therefore, the two masses which are interconnected, are the 10 kg block and the 6 kg sphere, and therefore both have to have a common acceleration, because the 6 kg sphere cannot accelerate more than the 10 kg block, since they are connected by a rope which cannot extend. So the F is equal to ma applies here. Instead of m, we put total masses, and instead of a, we put the common acceleration. Therefore, the concept of common acceleration has come for the system. So here we have to think at the system level. The backward frictional force is of course equal to mu k into n, where n is a normal reaction. Now, with that understanding of the net force, and we'll keep coming back to this net force, F net becomes m plus m into a, which is 10 kg plus 6 kg into a, which is 16a. On the other hand, the block is certainly accelerating from left to right, which means that the pulling force of the rope tension T is greater than the backward dragging force of the frictional force, which is F kinetic. So net force F net is equal to T minus F kinetic, which is T minus mu k into n. The normal reaction for a horizontal plane is easy to find. That's mg, which is straight away 10 into 9.8, which is 98 Newton. We get one of the answers. The kinetic friction value is already given in the problem, and we'll use it to get some of the other answers. I hope this particular slide was clear. Now the frictional force F kinetic is mu k into n, so we simply multiply 0.05 into 98, that gives us 4.9 Newton. So coming back to the net force, we always keep coming back to that, and that's equal to T minus 4.9. But we don't know T. To find T, we must get the free body diagram for the sphere which is hanging from the pulley. Now if we consider the sphere, then the upward rope tension is equal to the downward weight of the ball, because the rope and the ball are not having any motion relative to each other. Therefore, T is equal to mg, which is 6 kg of the sphere, into 9.8, which is 58.8 newtons. So we have got the rope tension now. So coming back to the net force, we simply substitute that, and we get the net force as 53.9 newtons. Now this net force is extremely important. This is what is acting on both the masses. Finally, we substitute the net force into the 16a that we found earlier. So 16a is equal to 53.9. Therefore, the acceleration of the combined masses is 53.9 divided by 16, which makes it 3.37 meters per second square. And because the rope does not have a mass, the block as well as the sphere will both accelerate at 3.37 meters per second square. The sphere accelerates downwards and the block accelerates from left to right. That's the only difference. I hope this explanation was kind of clear to you. Thanks and have a great day.